Hey friends, I am here with yet another video of DevWorld. I hope you have watched the previous videos of DevWorld. If not, please follow the link which I have given in the description box. So today, in this video, we're gonna talk about the Docker networking and different Docker networking options. So what is Docker networking? Docker networking is a communication passage through which all the isolated containers communicated with each other in various situations to perform the required actions. First, let's check the workflow of Docker. A developer writes a code that specifies application requirements or the dependencies in an easy to write Docker file. And this Docker file produces Docker images. So whatever dependencies are required for a particular applications are present in this image. Now Docker containers are the runtime instance of Docker image. These images are uploaded into the Docker registry. From the Docker registry, you can pull your image as well, and also you can upload your own images. Then from Docker registry, various teams such as development or production teams will pull that image and prepare their own containers. These individual containers communicate with each other through a network to perform the required actions, and it is called Docker network. Before we go with Docker networking types, let's see some useful Docker networking commands. The Docker network is the main command for configuring and managing container networks. Let's see the subcommand of Docker network. Docker network connect. Connect a container to a network. Docker network create. Create a user-defined network. Docker network disconnect. Disconnect a container from a network. Docker network inspect. Display detailed information on one or more networks. Docker network ls list networks. Docker network prune remove all unused networks. Docker network rm remove one or more networks. Docker supports different types of network drivers, each fit for certain use cases. They are bridge, host, overlay, MAC-VLAN, and none. We are using -d or -- driver option along with Docker network command to create user-defined networks, and also using -- network option along with Docker run command to run a container in a particular network. Bridge. If you don't specify a driver, this is the type of network you are creating. So all containers get an internal IP address, and these containers can access each other using this internal IP. The bridge networks are usually used when your applications run in standalone containers that need to communicate. By default, the Docker server creates and configures an Ethernet bridge device on the host system called Docker 0. Docker will attach all containers to a single Docker 0 bridge, providing a path for packets to travel between them. A bridge network uses a software bridge which allows containers connected to the same bridge network to communicate. The Docker bridge driver automatically installs rules in the host machine so that containers on different bridge networks cannot communicate directly with each other. Host. This driver removes the network isolation between the Docker host and the Docker containers to use the host networking directly. The host networking provides higher performance and eliminating the need for NAT. However, it does suffer port conflicts. So with this, you will not be able to run multiple web containers on the same host on the same port, as the port is now common to all containers in the host network. None. In this kind of network, containers are not attached to any network and do not have any access to the external network or other containers. So this network is used when you want to completely disable the networking stack on a container and only create a loopback device. Overlay. As discussed, the bridge network is a private default internal network created by Docker on the host. So all containers get an internal IP address and these containers can access each other using this internal IP. But how Docker containers on different Docker hosts interact with each other? This is where the overlay network driver comes into play. Overlay network driver creates a distributed network among multiple Docker daemon hosts. This network sits on top of the host-specific networks, allowing containers connected to it to communicate securely when encryption is enabled. Docker transparently handles routing of each packet to and from the correct Docker daemon host and correct destination container. This type of network driver is most commonly used in the Swarm cluster. MAC VLAN. Some applications, especially legacy applications which monitor network traffic, expect to be directly connected to the physical network. In this type of situation, you can use the MAC VLAN network driver to assign a MAC address to each container's virtual network interface, making it appear to be a physical network interface directly connected to the physical network. It's a very lightweight driver because rather than using any Linux bridging or port mapping, it connects container interfaces directly to host interfaces. Now let's look at some commands associated with networking in Docker. In terminal, type docker network ls. This command will list existing container networks on the current Docker host. The output shows the container networks that are created as part of a standard installation of Docker. When you initially install Docker, the platform automatically configures 3 different networks that are named None, Host and Bridge. You can see that each network gets a unique ID and name. Each network is also associated with a single driver. Notice that the bridge network and the host network have the same name as their respective drivers. If you type the command ifconfig, you could see the interface Docker 0 added into the Docker host. The Docker 0 bridge is a virtual interface created by Docker. All the Docker containers will be connected to the Docker 0 bridge by default. The Docker containers connected to the Docker 0 bridge could use the IP tables NAT rules created by Docker to communicate with the outside world. If you want to view details on the bridge network, you would type docker network inspect bridge. Bridge should be the name of bridge network. The output of the command would give you all the information you need about that network. These details include name, ID, driver, IPAM driver, subnet info, connected containers and more. I am going to demonstrate how to create a bridge network and then show you how to deploy a container on that network. We will create a network called DevBridge. Type docker network create -d bridge DevBridge. The output of that command will be a long string of characters that represents the ID of that newly created network. Run the inspect command on that newly created network with the command docker network inspect DevBridge. You could see our new network has been automatically given its own subnet and gateway. But what if you want to create a network with a specific subnet and gateway? That's possible as well. Let's say you want to create a network with a subnet of 192.168.2.0/24 and a gateway of 192.168.2.10 and the name Dovebridge 1. Type docker network create dash d bridge dash dash subnet equal to 192.168.2.0 slash 24 dash dash gateway is equal to 192.168.2.10 Dovebridge 1. Once created, inspect the network with the command docker network inspect Dovebridge 1 to see the results. Let's attach a container to Dovebridge network. Create a container called box1 and attach the container box1 to the Dovebridge network. Hope you have already pulled down the Nginx image. To do this, type docker run dash dash network equal to Dovebridge dash d dash dash name equal to box1 Nginx. If you want to attach a network during docker run command, you have to use the option dash dash network. Now run the command docker network inspect Dovebridge. You will see the container box1 has been attached to the user-defined bridge Dovebridge. Any other container you create on this network would be able to automatically connect to one another. Now we have added two user-defined bridge, Dovebridge and Dovebridge 1. Dovebridge is using 172.19.0 range IP and Dovebridge 1 is using 192.168.2 range IP. Since container box 1 is connected to Dovebridge, definitely the box 1 will get a 172.19.0 range IP. Suppose the container box 1 want to communicate with user-defined bridge Dovebridge 1, you would type docker network connect Dovebridge 1 box 1. If you type docker inspect command, you could see both Dovebridge and Dovebridge 1 are added into the container box 1. To disconnect the container box 1 from the user-defined bridge Dovebridge 1, use docker network disconnect command. Type docker network disconnect Dovebridge 1 box 1. Type the docker inspect command and confirm that the container is disconnected from Dovebridge 1. Now let's create another container box 2 on Dovebridge network which the box 1 container is available. Type docker run dash dash network Dovebridge dash d dash dash name equal to box 2 Nginx. Initiate docker network inspect command with container format option against Dovebridge and verify that both box 1 and box 2 is attached to Dovebridge network. You could see both containers are connected to the network Dovebridge. Now access the shell of box 1 and initiate the command ping box 2. See the container name box 2 is resolving from box 1. This is one of the big advantage of user-defined network. User-defined bridges provide automatic DNS resolution between containers. Containers on the default bridge network can only access each other by IP addresses unless you use the dash dash link option. Let's disconnect box 1 and box 2 from Dovebridge network and type docker network prune. This command will remove all custom networks not used by at least one container. Enter Y. You can see Dovebridge and Dovebridge 1 has been deleted. Initiate the command docker network ls and verify that custom networks are removed from Docker host. In this demonstration, I will create two bridge network, DoBridge 1 and DoBridge 2. Then I will create three containers. Let's call these containers as box 1, box 2 and box 3. Instead of allowing these containers in the default bridge network, we will put box 1 and box 2 on DoBridge 1 and box 3 will put on DoBridge 2 network. Since box 1 and box 2 will running on the DoBridge 1 network, obviously they can ping each other. But box 3 is on different network. Box 3 should not be able to ping box 2 and box 1. My motto is to parallelly run one container on multiple networks. What I do is, once this network is established, I will put box 2 on DoBridge 2 network. So the container box 2 will be parallelly running on both DoBridge 1 and DoBridge 2 network. Because the container box 2 is running on both networks, it can ping with box 3 and also ping with box 1. But box 1 and box 3 direct communication should not be allowed. This is the environment we will have to set up. Go to the terminal. Let us first create two bridge network DoBridge 1 and DoBridge 2 using docker network create command. When we are create the bridge network, the -d or -- driver option is optional. You don't specify the driver option, by default it's going to create a bridge network. To create null or MAC VLAN network, this option is mandatory. So now two bridge network are created. Initiate docker network ls and you should clearly see that two bridge network DoBridge 1 and DoBridge 2 are created. Let's create the containers box 1 and box 2 on DoBridge 1 network. Type docker run -d --name box 1 --network DoBridge 1 nginx. Same like create box 2 container. Run docker network inspect command and check both box 1 and box 2 is connected into DoBridge 1 network. Now create box 3 container on DoBridge 2 network. Once box 3 is created, let's go to the box 1 container and ping box 2. Since box 1 and box 2 will running on the DoBridge 1 network, obviously they can ping each other. Now let's ping box 3 container from box 2 container. Obviously it is not reachable because those are in the different network. As discussed earlier, I want to parallelly connect the container box 2 on both network DoBridge 1 and DoBridge 2. So you would type docker network connect DoBridge 2 box 2. Initiate docker network inspect command against DoBridge 2 and verify that the box 2 is attached to DoBridge 2. Now let's try to ping box 3 from box 2 container. See, we are able to ping box 3 container from box 2. Let's try to ping box 1. Obviously they can ping each other. Now box 2 can able to communicate both box 1 and box 3 container. Let's go box 3 container and initiate the ping command against box 1. It won't be able to ping because box 1 and box 3 direct communication is not allowed.